Namaste. I, JV'n Narendra Chahar, Assistant Professor in Department of Science and Technology under Faculty of Education and Methodology in Jayoti Vidyapeeth, Women's University, Jaipur. So, in the previous sessions, we have discussed about technologies for handling big data. We have discussed the distributed and parallel computing for big data, introduction to big data technologies, cloud computing and big data, in-memory technology for big data, and now we are going to discuss big data techniques. Here we will discuss about some terminologies to analyze the data sets. So there are many techniques available out there. Some of them are here: massive parallelism, data distribution, high performance computing, task and threat management, data mining and analytics, data retrieval. So the first one is massive parallelism. According to the simplest definition available, a parallel system is a system where multiple processors are involved and associated to carry out the concurrent computations. The massive parallelism refers to a parallel system where multiple systems interconnected with each other and pose as a single mighty conjunct processor and carry out tasks received from the dataset parallelly. So, in terms of big data dynamics, the system cannot only be processor but also memory, hardware, and even network conjunct to scale up the operational efficiency, posing as a massive system that can eat homogeneous datasets parallelly without breaking a switch. That means we are parallelizing systems at a large amount. Just like we are just jointing the processors alongside, so they can behave just like a single processor, and we are adding to the memories. Just like if I'm adding five memories, so the end of the second memory and the start of the third memory will show the block numbers next to it. Now we will talk about data distribution. So there are some approaches of data distribution and big data system described as centralized approach, semi-centralized, hierarchical, and P2P. So in centralized approach, we discuss about a central repository which is used to store and download the essential data set by virtual machines. Just like we have a server and host model. A server has a control and other nodes or other systems, we can say hosts, only store the data which record is found on the server. Next one is semi-centralized approach. The semi-centralized approach reduces the stress on networking infrastructure. Just like we are assigning some systems a some limited control so that they can manage at their own, so that the completely burden will not be on the server. Now the third approach is hierarchical approach. So in the hierarchical approach, the data is fetched from parent node, the virtual machine, in the hierarchy. Just like we have the tree system here, the data is here and a parent node is there. So the data is fetched from the parent node and then it is used. The last one is P2P approach. Now, P2P streaming connections are based on hierarchical multi-trees. We talk about heap, just like in the heap there are distributions about the trees, and a single node or on a single line there are nodes that are master node. But here we talk about multi trees. There are many trees there. We can differentiate with the subtrees also. Now the third one is high performance computing. The high performance computing is simultaneous use of supercomputers and parallel processing techniques for solving intricate computation problems. It emphasizes on making parallel processing systems and algorithms by joining both parallel and administrative computation methods. In words, supercomputing and high performance computing are often used to resemble each other. Just like we are using supercomputers for high performance computing, and we are just computing at a high level or high performance computing. So we need some expensive or extraordinary hardwares there. Just like in supercomputer, there are some circuits which do the work very fast, and chips to do the work or to execute the instruction as soon as they get the instruction and give the output. The high performance computing is used for performing research activities and cracking advanced problems through computer simulation, modeling, and analysis. So, there are three things. These are simulation, modeling, and analysis. So, when we talk about simulation, it's some kind of we are just doing it on a virtual mode, or we are just performing the practical implementation of the real time problems or the problem we got. In the modeling, we prepare the model of it, and the last one is analysis. So we analyze the simulation and the modeling, how it works and what are the outputs. Now we will talk about the task and threat management. So how to manage the tasks and the threats out there. When we talk about threads, so these are simply OS based features with their OR kernel and memory resources, and allow an application logic to be segregated into concurrent multiple execution paths. Just like we have some kind of program which is running on operating system. This will run at their own, and now it has multiple execution parts. Just like it will behave as it is legitimate or is not harmful for the computer, but sometimes it behaves like uh, if it is stealing some information or sending somewhere else, or a backdoor. Someone might log in into the system if he has the network access or login credentials. So it is useful feature when complex applications having multiple tasks need to be performed at the same time. Now, the task parallelism refers to the execution of computer programs throughout the multiple processors on the different or same machines. It emphasizes on the performing diverse operations in parallel to best utilize the accessible computing resources like memory and processors. In this, the operations are performed in a parallel way where the computing resources are parallelized, just like memory and processors. As I discussed previously, all processors are jointed and then they behave like a single processor, and compute uh, the computing efficiency will be increased number of times. Now we talk about the data parallelism. It focuses on the effective distribution of datasets throughout the multiple calculation programs. So there are many programs out there, and what is the effective one? We have to choose that, and we perform the operations. Now, the data mining and analytics. So we just see the data mining and analytics. So the data mining is the process of something extracting from somewhere, and analytics part is to analyzing that data. So when we see in the details, the data mining is the process of data extraction, evaluating it from multiple perspectives, and then producing the information summary in a meaningful form. Just like we are accessing some information and we are evaluating that, and then we are just fetching the best out of best information, and we are just making a summary out of it that describes the best. So it might be one or more relationship within the data set. The data analytics analysis is the experimental activity where the data sourcing gives out some insight. Just like we are analyzing some data, we are just creating a graph out of the data, and we are just seeing the how the graph goes. It's like it's going up or down, or what are the values out there. So these are the things in data analysis. And see, the data analysis and data analytics are some different terms. Data analysis is simple. When we talk about the data analytics, it is about applying an algorithm or a logical process to derive the insights from a given data set. Because we see all the aspects in reference to the algorithmic and logical processes. For example, looking at the past year's weather and pest data for current month, we can determine the particular type of fungus grows often when humidity level reaches the definite point. So we can analyze that. Now we talk about the data retriever. So we are talking in context of big data now. So big data refers to a large amount of multi-structured data that continuously flows around within an organizations, including text, video, transactional records, and sensor logs. So the log files maintain all the details of the system. Now, big data systems utilize the Hadoop and the SDFS architecture to retrieve the data using MapReduce. MapReduce is a distributed processing framework. It helps the programmers in solving parallel data problems where the data set can be divided into small chunks and it can be handled autonomously. MapReduce is an important step as it allows normal developers to utilize parallel programming concepts. It is irrespective of cluster communication details, failure handling, and task monitoring. Now, the machine learning. What is the machine learning? So, formally, it focuses on performance. It is a theory or in properties of learning algorithms and systems. Just like we have a system, and there are some algorithms that need to be executed, or those are specific algorithms for special purposes. So, how the machine will recognize that? The machine learning is considered an ideal research field for taking advantage of the opportunities available in big data. As like we discussed about big data, so there are things that need to be automated. So we need the algorithms. So we are doing something that machine can face the data and take the decisions. Just like we talk about the auto scaling, where we have mm, a machine which is utilized more than 80%. So it is clear to create a new machine automatically when it needed with the same configuration and the storage available there. So it is automatically created. What is machine learn here? Machine learn that when the 80% will cross, then I have to create a new machine with the same configuration, and that's it. So it delivers on the potential of mining the value from huge and different data sources with less dependence on human instructions. It is data driven and runs at machine scale and well suited to the complication of dealing with different data sources and the enormous range of variables and quantities of data involved. Machine learning systems utilize multiple algorithms to discover and show the pattern hidden in the datasets. Now, the next one is data visualization. So, how we visualize the data? Just by creating some graphs on some typical statistical and computation results, which can be analyzed and that those are visualized just like we create a pie chart to show the results in Excel. So data visualization is a valuable means through which the larger data sets, after being combined, may appear practical, sensible, and open to most people. So data visualization is a trailblazing method that not only keeps you enlightened but helps other with the attributes of typical statistical and computational results that would have otherwise appeared intimidating for normal minds. So the visual representation is often considered the most effective medium of information and communication channel. As the saying goes, a picture is worth thousand words. Data visualization is a great example of saying that saying. When properly aligned, it can convey critical information of data analysis in probably the easiest way possible. So we can visualize the data. If we have the results, so we just visualize the data and we show that visualized data to the user or someone who want to see that. So it will be easy to understand that. Now, some of our session. Thus, we talked about the distributed computing. So, the distributed computing works on the rules of divide and conquer. Just like we divide uh, the task and we are performing on the different machines, and then we are assembling all the subtasks to a single task. So, performing module of the parent task on a multiple machines, then combining the results. Now, we talk about the parallel computing. So, it refers to the utilization of a single CPU present in the system or a group of eternally coupled systems by means of efficient and clever multi-threading operations. When we talk about the multi-threading, so there is a single processor and we are just creating threads out of it. So that there can be some multiple processes can be executed on the single system. So the distributed computing is considered as a subset of parallel computing, which further is the subset of concurrent computing. At the end, uh, the big data system is vastly different from the solution providing systems, and it is based on 7 V's as we discussed: volume, velocity, variety, veracity, variability, value, and visualization. So we have discussed all these things. Now, time to sum up the session. Thank you.